All right, class, let's move on to solving quadratic equations. So before we go on to our big sections of that we'll cover next on quadratic functions, let's recall how to solve quadratic equations. Okay, so a quadratic equation has the form ax squared plus bx plus c equals to 0. What makes it quadratic is the fact that the highest exponent of the variable is a 2. So if you remember equations, just sum x plus c, where the highest exponent was 1, that was what we dealt with the whole last chapter. Those were called linear equations, and we had one way of solving them. Now, what we're going to see is definitely an x squared, okay? And not only we're going to see an x squared, but we are going to see an x squared, as in you might be missing the x term, you might be missing the constant term, but you will definitely see an x squared every single time in your equation, okay? All right, now, hopefully you have covered these. Again, this is college algebra, so that means you've had several levels of algebra prior to this class. And you will have already solved quadratic equation plenty of times. I still would like to go over it and review with you. So the easiest way to solve a quadratic equation, and if it's possible at all, is by factoring. So again, not every quadratic, again, this is what quadratic equations will look like. See, you see an x squared every single time. Maybe you see the x term as well. Maybe you're not. Maybe it's missing. Maybe the constant's missing. But every single time you do see an x squared somewhere there. Okay, so if you can factor these expressions, which we're going to review in a minute, then that's the easiest way to solve the equation, right? However, not every quadratic equation is going to be factorable, and then we're going to explore other methods. So, how does factoring work? Okay. By the way, I've also, even though we are not going over the section 3.0, which is kind of like a review for chapter 3, I did post on Canvas a section called a textbook for 3.0, which is just review of factoring. So if you need any more help with factoring, I very much suggest that you read that textbook as well, that section as well. And get familiar, because factoring is going to be very important, not just in this chapter, but in many chapters to follow. Okay, so here it is. Now, when we're just talking about factoring. So if you remember, there are several factoring methods. Is factoring greatest common factor, factoring by grouping, factoring trinomials, and factoring differences of perfect squares. Okay, so the order in which we're going to factor is following. Anytime, no matter what, to factor an expression, we're always looking for a greatest common factor. And of course, if there's a leading negative, it means basically your expression starts with a negative, then you would want to factor that as well. Okay. If you ever see 4 terms, which we're not really going to see in this section, but definitely in the next chapter, anytime you see 4 terms, you're always thinking about factoring by grouping. So review that. 3 terms is really what we're going to see most of the time in a quadratic. 3 terms, that's exactly what a quadratic equation has. 3 terms, yes. We will definitely use factoring methods for ax squared plus bx plus c, which you see looks exactly like your quadratic equations term, or x squared plus bx plus c. Now, you might be wondering, isn't this the same thing? Not quite. The second expression, what happens is that the a value at the front is equal to 1. So if you don't see a coefficient in front of x squared, that means it's a 1, and then factoring is much easier for that. So then if there is a number in front of x squared, we have different methods. Okay, so all of this, I very much strongly encourage you to review on factoring methods if you know you don't know it, okay, or you are not as good, or it's just forgotten. Please go back and read that Introduction 3.0. I will try as much as I can in this section to remind you of factoring as well. But yes, it's just a reminder. And then also happens quite a lot with quadratics is that you get what's called the difference of squares. We don't really have sum and differences of cubes in what we will be doing this chapter or the next, so don't really worry that much about factoring sums and differences of cubes, but definitely factoring differences of squares. So you will see just 2 terms in that case. Okay, so as we encounter these methods, I will remind you of how to factor. Now, once our quadratic equation is factored, we are going to use, this is the rule that we use in order to solve the equation. It's called the zero product rule. So the zero product rule needs exactly these 2 quantities. It needs a 0 and it needs a product. So here it is. The zero product rule says that if you have a product, you're multiplying 2 or actually more quantities together and the answer equals to 0, so the product equals to 0, then the only way that's going to happen is one of the factors must equal to 0. Either A is 0 or B is 0. But what we're saying is there's no way you're going to multiply 2 non-zero numbers, or 2 numbers that don't equal to 0, and the answer is going to come up 0. It's not going to happen. Okay, so here it is. We already talked about what a quadratic equation is. So here it is. Solve the following quadratic equations by factoring. And that's because you can factor. So here it is. To solve a quadratic equation, 2 things must happen. It has to have all the things on one side of the equal, and on the other side, it has to equal to 0. So if not, you're going to need to move all the terms to one side. It has to equal to 0 because you need to use the zero product rule. Now, the second part of the job, once we have it equal to 0, we need to turn the left-hand side into a product. Well, this is what factoring does. Factoring takes a sum and turns it into factors, in other words, products. So here are the methods. If I look at this trinomial, I see 3 terms. And what I see is that it starts with a 1x squared. So therefore, I'm using this method of factoring trinomials of this form. So a method works following. I will always open 2 parentheses because that's my product right here. And so in these 2 parentheses, the x squared comes from x and an x. Okay. And then I have to think about what? 2 numbers that multiply to -6 and add up to this positive 1 that I have in front of x. So what kind of numbers multiply to -6 and add to 1? Well, because the 2 numbers multiply to a -6, yes, that means 1 has to be a positive and 1 has to be a negative. And because whenever you add a positive number to a negative number, you actually subtract them. So the answer to a +5 added to a -2 is a +3. You actually subtract the numbers and you keep the sign of the larger number. So our question really becomes, which 2 numbers that multiply to 6 subtract to equal to 1? And those numbers are 3 and 2. a positive 3 and a negative 2. So let's see if these two numbers fit the description. Do they multiply to negative 6? Yes. Do they add to a positive 1? Yes. So we factored correctly. Again, this is just the factoring part of the problem. Now that we factored this trinomial, so we rewrote this sum and differences of terms as a product. Okay. That equals to 0. We're going to use the product rule that says, okay, well, a product is equal to 0, then either x plus 3 is 0 or x minus 2 is 0. I only have these two options. Now, either one of these equations is now a linear equation. X is to the power of 1. So to finish solving for x, I'm going to minus 3. To finish solving for x, I'm going to add 2. And here are my two solutions. Okay. By the way, a quadratic equation is going to have two solutions. Okay. If you recall, a linear equation, like the ones we did last chapter, each have one answer only. Yeah, so the power, the highest exponent of the variable, will always tell you how many answers you're going to get. All right? So that's how this works. We're just going to do it faster now. So I need to solve by factoring. It equals to 0, so we're good there. Now I'm taking this trinomial here and I'm going to write it or rewrite it as a product of factors. So x squared comes from an x and an x. Numbers that multiply to negative 10 and add up to negative 3. So in other words, numbers that multiply to 10 and subtract to be 3 are easily 5 and 2. Not many numbers multiply to 10. Now many numbers multiply to 6. Yes. But once you have them, don't just assume that it's correct. You have to always check your answers. Okay, make sure you have the signs correctly and you have the numbers correctly. So indeed, a negative 5 added to a positive 2 is the negative 3. A negative 5 times a positive 2 is the negative 10 out here. You can also check if you want. I'm just going to do this really quick. If I distribute these two parentheses, what do I get? X times x is x squared. X times positive 2 is 2x. Negative 5 times x. And negative 5 times 2 is negative 10. So there you have it. Why? These two numbers have to add to negative 3 in the middle, because that's how you get that negative 3x, by combining these like terms, right? And where did the negative 10 at the end come from? It came from multiplying this negative 5 to a positive 2. So we have factored correctly because multiplying these two parentheses gives us back those terms. So just wanted you to see how this math actually did work and we did factor correctly. However, the point of factoring is not to just multiply right back. I just wanted to check though for us. The point of factoring is that we can now use the product rule that says either x minus 5 is 0, which makes x equal to 5, or x plus 2 is 0, which makes x equal to a negative 2. Again, how? Because again, I'm adding 5 to both sides. I'm minusing 2 from both sides. All right. Here to remind you is a different factoring method. I don't see a trinomial anymore, so not 3 terms. I only see 2 terms. Whenever I see 2 terms, I'm thinking, is this a difference? Yes, it is. And are these 2 terms both perfect squares. By perfect square, we mean is a number times itself gives you that. So if this indeed is a difference of perfect squares, that's how they factor into every single time. The x squared comes from an x and an x, a plus and a minus every time. What times itself gives you 9? 3. So the reason this works, I'm going to check really quick here for you to show you why we end up with just 2 terms, is because when I distribute x squared, x times x is the x squared, minus 3x, and then plus 3x. And then minus 3 times 3 is minus 9. So what happens with these 2 terms? They add up to 0. So really, it is a trinomial, but we have 0 x's in the middle. There's no x. And so therefore, I need to think of numbers that multiply to negative 9. Or in other words, multiply to 9 and subtract to be 0, right? So again, because they multiply to a negative, they have to have different signs. And when you add a 3 to a negative 3, they would add up to the 0, x in the middle. All right. So that's how factoring differences of perfect squares works. And here are my options now. Again, either x plus 3 is 0, which makes x equal to negative 3. Or x minus 3 is 0, which makes x a positive 3. All right, and for the next one, there's another method. Okay, as you see, this is a trinomial. However, the coefficient in front of x squared is not a 1. Okay, so therefore, we have to use methods of factoring some ax squared plus bx plus c. And there are 2 different methods of factoring such a trinomial. I personally like one that we call the trial and error method. And this is how it works. At the first, when this was a 1, I would just put an x and an x at the front because that's what got me the x squared at the front. However, this time I don't just have a 1x squared. I have a 3 times x squared. So I also have to split up this 3. Same thing at the end. These 2 numbers are going to be numbers that multiply to 2. And numbers that multiply to 2, I don't have too many options, or 2 and 1. Again, that's not the method where there's a 1 here. So these 2 numbers are not going to multiply to 2 and also add to 5. That's the method we use if it has a 1 at the front. If it doesn't have a 1 at the front, you're not looking for those kind of numbers that multiply to 2 and add to 5. You're just looking for numbers that multiply to 2. That's it. Okay. So, again, it's a positive 2. Therefore, I'm going to put 2 pluses. And we didn't do anything about the 5. Okay. So we have to check to make sure we indeed are going to get a 5x in the middle. So here it is. I'm going to check the whole thing for you just to show you. If I distribute this, I'm getting my 3x squared at the front, which, I split the 3x squared into 3x and x. So, of course, I'm going to get it back. Plus, 3x times 1 is 3x. 2 times x is 2x. And 2 times 1 is the 2. Now, these first and last are going to be 3x squared and 2 because you chose these numbers to multiply to 3x squared and the 2. But what you need to check is really just the O and I of FOIL. And you need to check, do these 2 middle terms add up to this 5x in the middle? And yes, they do. So you don't need to check the front and the last. You just need to check the outers and the inners and see if they multiply to give you the positive 5 you have. And they do. So, in other words, we factored correctly. All right, so because we factored correctly, we can go on and finish this problem. Okay, what do I mean by finish this problem? Use the zero product rule to say that my options are for either one of these factors to equal to 0. And here I'm going to minus the 2 and divide by 3. Here I only need to minus the 1, and then x is by itself. So you still need to finish solving for x, each one of these linear equations. Minus 2 divided by 3, and so on. Alrighty, so kind of these are the only factoring methods you're going to be faced with. Factoring differences of perfect squares, as I said, and factoring trinomials, the kinds that start with 1 and the kinds that don't start with 1. So let's see what we have and what else we can do. So here I've changed them slightly for you a bit, because the first thing you need to make sure happens is that it equals to 0. So what I need to do is I need to minus the 75 over to make sure it equals to 0. And now I can go on to factor. Now, one thing we haven't really looked into, but it's also possible, is there a greatest common factor? Okay. And none of these problems we had a greatest common factor so far, but this one does, because if you look, 3 and 75 can both be divided by a 3. So therefore, 3 is a greatest common factor. So once we factor it out, this is what we get. So to factor out a greatest common factor means to divide all the terms by that greatest common factor. We'll pull it at the front. And now as you see in the parentheses here, I have 2 terms only. And 2 terms always makes me think of, is this a difference of 2 perfect squares? Yes, it is. And that's how we factor it. Split up the x squared into the 2 numbers that multiply to it. Always a plus and a minus, or a minus and a plus, but point is they're different signs. And the number that times itself gives you 25 is 5. Okay. So either x plus 5 is 0, which makes x equal to negative 5. Or x minus 5 is 0, which makes x equal to 5. So these are my 2 solutions. So quadratic equation is going to give us 2 answers. Now, you're probably wondering, what about 3? Well, what about 3? In this product, one of the numbers is going to be 0. Is 3 going to be 0? No, 3 is 3. 3 is a numerical factor. It doesn't change values. It stays 3. So you don't need to worry about 3. 3 is not going to be 0 because 3 is 3, right? X variables, X expressions can switch values. They vary. Yes, okay, can become 0. So when can x plus 5 become 0? Well, x plus 5 can become 0 if x happens to be negative 5. Can x minus 5 become 0? Sure, if x itself is 5. So here are your solutions. Okay. All right, so remember, a quadratic equation is going to have 2 answers. This one's a little funny because it doesn't look quadratic at all, but what this equation here has is a fraction. So we want to make this equation prettier. Therefore, I'm going to multiply both sides by the least common denominator here, which is the x. So that kind of brings back some of the other methods you've learned when solving equations. One of them was clear the fractions if you have them. Of course, in our class, we use calculators a lot. If we have fractions that are numerical, no big deal. You can put 2/3, 7/5, 9/22 in your calculator. We don't necessarily need to clear the fractions in those cases. However, if you have an x in the denominator, you can't put that in your calculator. So let's get rid of it. Now, when I multiply by x, I'm going to have to multiply everything by x, both sides. So as you see, I'm getting a 15x squared minus x times 4 over x. That makes the x's go away, so I'm left with just the 4 equals to 4x. All right, so it needs to equal to 0 before I factor. So therefore, I subtract 4x from both sides of the equation. And because we always want the terms to be in what we call descending order of exponents in order to factor, I'm tucking that negative 4x in the middle between x squared and the no x. And now we can go ahead and factor. So think about numbers that multiply to 15. I'm going to try the mainstream ones, 3 and 5. Think about numbers that multiply to 4. And I'm going to try the mainstream 2 and 2. So see how this is a minus, so that means I need a plus and a minus, right, to multiply to a negative 4. All right, so let's see if we have the right answer for the O and I. So I'm just multiplying the outers and the inners. So 2 times 5 is 10. 3 times negative 2 is negative 6. 10 minus 6 would get me 4x. Do I have a 4x in the middle? No. I have a negative 4x, which means the numbers are good, the signs are not. So make this a plus and make this a minus. And now if you try, you see how you get a negative 4x in the middle. Okay, so that's what we mean by trial and error. You throw on some factorization. If it doesn't work, swap the factors, swap the signs. See what else you could do to get the middle term. And then after this is a simple linear equation that we practiced already plenty on solving. Okay, here are 2 more on factoring. Again, especially with bigger numbers, think about, is there a greatest common factor? But there's not. It's a trinomial. It does not start with a 1, so therefore it's the trial and error method. So split up the 4x squared, and I'm going to split it into a 2 and a 2. Split up the 9 at the end. I'm going to try 3 and 3. These are the most mainstream numbers. If they don't work, then I can go and try 1 and 4 for the 4, or 1 and 9 for the 9. So let's see if the outers and the inners would get us a total of 12 in the middle. And they do, right? 6 plus 6 is 12. So correct, we factored correctly. We will get the 12x term in the middle. So solving these equations, you might already notice that actually they're both the same equation. So no matter what, I'm going to get the same answer. So that's totally possible. We technically do get 2 answers. However, they're identical to each other. So we call this a double answer. So, or an answer of multiplicity 2. So this answer comes up twice. As a matter of fact, this equation or this expression here is going to turn into 2x plus 3 quantity squared equals to 0. So it's really one and the same factor. So you really don't need to solve it twice. One answer is enough because that's really what we get. So yes, we get two answers. It's a quadratic equation, but they are identical to each other. All right, so here's the last one by factoring. We're going to try our luck on factoring one more time. First thing you need to do is have it equal to 0. And then see if you can split this trinomial. Again, numbers that multiply to 2x squared are 2x and x. Numbers that multiply to 21 are 7 and 3. And now if I try, that's 7. Minus 6. 7 minus 6 does not equal to 11. Okay, so changing the signs won't help us. That would just give us minus 11. So what we can do is swap their places. So in other words, put the 3 here and the 7 here. They still multiply to 21, but these values have now been paired up differently. So let's see if we get that. So 3x here, negative 14x here, that equals to a negative 11. That's way better, but I need a positive 11, so therefore I'm just changing the signs. So there you go, I'll get a minus 3 plus 14, which is the positive 11. So that's the trial and error method. Just throw on factors. If it doesn't work, swap them around, try new factors until you get the result you want in the middle. And everything, therefore, matches up. Right, and that's the finish off of it. Now, that's factoring. Make sure you remember how to factor. It's going to come back to us in other chapters. Using the square root property can also be helpful because many times we don't necessarily even need to factor. We can't, and yet we can easily solve the equation. So what's happening in this square root property, you see the x squared term being isolated, and then there's just a number on the other side. So there is no x term in these equations. So I don't mean you can use it if this has like a 4x on it as well. You can't do that. That's just not going to work. Okay. But this equation works kind of in the same manner that linear equations worked in chapter 2, because you got x to be by itself on one side of the equation. But however, you need to do one more step. And so to get x by itself, you will need to square root both sides. So get rid of the square. So here it is. I'll write it again. To get x by itself, all you have to do is undo the square with a square root. So many students will do that, and yet you will get not necessarily the wrong answer, but only half the answers. And the reason for it is because this is a quadratic equation, so you have to get two answers, yes? Now, those two answers are positive square root of 8 and negative square root of 8. Here it is. Because if I square the square root of 8, what do I get? Well, 8. What happens if I square the negative? Well, the negative times a negative also gives me a positive. So therefore, you get two answers, but don't forget to put the plus and the minus to it. All right. Now, for this square root property to work, you need to have x squared by itself. So here it is. To get x squared by itself, I can minus, and again, you see there's no x term there, right? Minus the 1 divide by 4. And now take the square root on both sides, and don't forget about plus or minus. So your answers can be just as pretty as plus minus square root of 1.5, which you can also put in your calculator and give me a decimal answer for it. That's fine. But don't forget the plus and the minus for your two possible answers. And so that's pretty fast. It's very rare for it to happen. So let me show you one more. Again, see how X shows up only in one place? All I want to do is remove everything that's been done to it. So this is what I'm going to do. What's been done to it is, first of all, a 3 multiplication. So I'm dividing both sides by 3. And so that makes it a 5, yes? Now, get rid of the square. To get rid of a square, we square root both sides. And at this point, the square root property says, yes, you can square root both sides, but don't forget to put the plus and the minus on the other side of X. So the square root makes the square go away. And I'm just leaving the answer as a plus minus square root of 5. You do not need to use your calculator. You can leave the answer in what we call exact form. So leave it with the square root. And then finally, to still get to X, I need to add the 4 over. And 4 cannot be really added to a square root of 5 unless we use a calculator. Or 4 minus square root of 5, again with a calculator. But we're going to leave the answer just nicely compacted as it is, 4 plus minus square root of 5. You can leave your let your calculator finish up the problem by doing, again, as I said, these two options, but you leave it like this. Don't worry about it. But these are your two options that you can put in your calculator to get decimal answers and therefore approximations. Now, the big one is solving quadratic equations by the quadratic formula. You absolutely must know the quadratic formula. It is, and I hope you already do know it, it is extremely helpful. It's going to keep coming up and we're going to need to use it. So this is one that you have to know. Okay, so whenever solving a quadratic equation, again, if we can factor it, great. You could get to the answer super fast. However, even if you can factor but don't know how, the quadratic formula works every time for any equation, factorable or not, square root property or not. So works for any quadratic equation. So if you do not know how to factor, no problem. Learn the quadratic formula, which you already have to know, and use the quadratic formula every single time. You will see you get your answers. Okay. So as a matter of fact, I challenge you to go back to either one of these equations and solve them with a quadratic formula. On a test, I will just say solve the equations. Now, what method you use is up to you. Okay, here it is. Solve by the quadratic formula. Now, first thing we want to do is still have it equal to 0. So in other words, move all terms to one side of the equal. Okay, and then we need to identify who are A, B, and C are, so we can put them in this quadratic formula. Now, A is the coefficient of x squared. That's a 1. B is the coefficient of x. That's a -5. C is the coefficient, the constant term, right? And that's a -1. So that's why it's important that you move all terms to one side. C is not equal to 1 because it's not on the same. They all have to be on the same side for me to identify what they are. Okay, so now all we have to do is take these numbers and put them into this formula that says x is going to equal to negative b. Well, our b is negative 5. Plus or minus the square root of b. If b is a negative, please put it in parentheses because 2 square b means to square the negative and the 5. That's what b is, a negative 5. Minus 4 times a is 1 times c is negative 1. All over 2 times a, which I grab 1 for. Okay, and now we still need to simplify. So even though, yes, here is an answer and this is a number, we need to use the order of operations to simplify it. So minus 5 is 5. Plus or minus the square root of negative 5 squared is a positive 25. Every time you square a number, you get a positive. And then plus 4, minus times a minus is a plus, over 2. So that's a 5, plus or minus the square root of 29 over 2. And here's your answer. This is also why I'm telling you leave the answer with plus and minus. It starts looking familiar, and there it is. Okay, next equation, it's already equaling to 0 and it's nice, but I don't really like to have decimals. It doesn't make it easy to simplify. So one way to get rid of decimals in an equation is to multiply both sides by whatever many zeros it takes to move the decimal out of the way. So 0.4 times 10 is 4. 2 times 10 is 20. 1.3 times 10 is 13. So now I have much nicer numbers to work with. And the numbers are 4, negative 20, and C is a positive 13. Okay. So that's what x is going to equal to according to the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's a 20 plus or minus the square root of 400. And this time is a minus. Let's see, 16 times 13 is 208 over 8. Okay, so that's going to be a 20 plus or minus the square root of 192 over 8. Now, these numbers still can be simplified. I will not mess with you on simplifying radicals, which is another topic that I hope you do remember. You can leave the answer just like that. You don't have to simplify it any further. This would be totally fine on a test, but I'm still going to show you how you would actually move on and simplify this answer, because the radical has to be reduced. So does 192 have any factor that are perfect squares? In other words, 4, 9, 16. So I'm taking 192 and see if I can divide it by 16. Oh, actually, I'm getting a 12. So 192 divided by 64 is 3. Yes. So that's the square root of 64 times 3. And the square root of 64 is 8. So that's what it meant to simplify radicals. And now when I nicely split up the 20 divided by 8 is 5 halves. I can reduce it by 4. Plus or minus 8 square root of 3 divided by 8 is just the square root of 3. So the answer is much nicer, or 2.5. 2.5 plus or minus square root of something. So what I'm saying is square root of 3. So what I'm saying is that these answers will really always come up to a number plus minus some kind of a square root value. So, but it's totally fine for me to leave the answer like this. All right, let's try a couple more. A is 3, and again, I very much encourage you to try these problems. Plug it into the quadratic formula and start simplifying, see how far you get. Now, this time, what I'm going to get inside the square root is a 1 minus 4 times 3 times 2. That's going to be a negative 23. And so this is why we talked about what happens when you have negative numbers inside a square root, and the fact that, yes, the answer is not real, not a real answer. If you put in your calculator is going to say not real. However, it's an imaginary number. So really the only thing that really mattered from the previous section is to know that a negative 1 factor inside a square root splits or spits out an imaginary answer for you. So really these are my answers: negative 1/2 for the real part, plus or minus square root of 23 over 6 many i's. So remember how I said imaginary answers, complex numbers have, or plus minus, a plus bi, a minus bi, really. Okay, so they have always this kind of format. Okay, so very much you can get imaginary solutions when solving quadratic equations. The point is you always get 2 answers. Or maybe, let's see what happens here. Negative b, which is a negative, plus or minus the square root of b squared minus 4 times a times c. So I know I have the other value in my face. Over 2 times a. So let's see, that's a 20 plus or minus square root of 400 for the negative 20 squared. Minus, that's a 400 as well. And so it happens, the square root of 400 minus the square root of 0 is 0, yes? And so whether you add 0 or you minus 0, you're still just going to get to 20. So we do get one answer only. Really, we got 2, but they're both the same. One answer is 20 plus 0 over 50. The other answer is 20 minus 0 over 50. And they both turned up to just 2/5. So by the way, we could have actually factored this. Anytime you get answers that don't have square roots, that means you could have factored the original problem. So if you try that, there you go. 5x and 5x at the front, 2 and 2 at the back, and both with a minus. And each one of those will get you an answer of 2/5. Okay. So as you see, we can get different kinds of answers. We can get 2 imaginary answers. We can get 1 real answer. We can get 2 real, but like with decimals. Or you can get 2 nice answers without decimals. So sometimes we might actually be interested in just what kind of answers can we get, the nature of the solution. So what type of answers? In other words, real, imaginary. So really what this depends on is the quantity inside the square root. So see how the quantity inside the square root turned up negative? We got complex solutions. If the quantity inside the square root turned up to be 0, we only got 1 real solution. And if it turns up to be a positive, then we get 2 real solutions. Okay. So that's exactly what it is. This quantity inside the square root, which is the b squared minus 4ac, that's what it depends on. If it's 0, we only get one solution. That's actually a rational number. No square roots left. If it's more than 0, if it's positive, then we're going to get two real solutions. Rational or irrational, but they're both real solutions. If you remember what we talked about since day one, if you are left with a square root, that makes for an irrational number. If you're not left with a square root, you get some ratio between integers that makes it a rational answer. And finally, if the quantity inside the square root is a less than 0, so a negative, then we're going to get two imaginary solutions. So we get i's in our answer. Okay, so we just want to know what type of solutions we would get. So that's all I want to know. What would 4b squared minus 4ac gonna equal to? Well, that's a 16 minus 16, which is a 0. So we're going to get one rational solution. It's fine if you just say real solution, but it's going to end up without square roots, so rational. Either one of these answers is correct to me. But we'll get one answer. Here, (14 squared minus 4 times a times 3). I'm going to use my calculator for this one. Minus 4 times 8 times 3. That's going to be actually 100. Okay. So when you get 100 inside the square root, that's going to be the square root of 10. So you're not left without the... But again, what I need you to simply recognize is that you will get two real solutions. The answer is positive. But also, yes, your answers will have no square roots in them, and therefore they will be rational. And here's the last one. Oops. I don't know why I said equals to 0. I meant to say equals 2 negative 5 squared minus 4 times 3 times 12. Remember, negative 5 squared is a positive 25. Every time you square a quantity, you'll get something positive. So I don't even really care about what number it is. I know that it's going to be a negative number. So therefore, I'm going to get two imaginary solutions. So we'll have i's in our answer. Or two complex solutions, if you want to say. All right, and this is it. This was a longer section. I do hope you guys know factoring, and if not, catch up with it, and please read the textbook and get help from the internet, or try and review your older algebra courses maybe.